Hello, this is TCG and welcome to the 7th lecture for the CompTIA Security Plus 601 exam. Let's get started. Application hardening. Application hardening involves securing an application and its environment to minimize vulnerabilities and reduce the risk of exploitation. Registry management. A registry is a database containing the configuration details of the Windows OS and applications installed on it. Registry management gives us direct control over the configuration of the operating system and the applications. Being able to look at the changes in the registry is very helpful for detection of threats. But Windows does not support this feature, so we use third party tools to show us the changes in the configuration over time. Disk encryption. Full disk encryption. It encrypts the entire disk, protecting all data stored on it. Common tools for FDE or full disk encryption include BitLocker and FileVault. Self-encrypting disks or SED. These are hard drives that automatically encrypt data using built-in hardware encryption. Opal storage specification. It is a set of standards for SEDs defined by the Trusted Computing Group or TCG to ensure interoperability and security. Operating system hardening. It refers to configuring the OS to enhance its security posture. Different operating systems, such as Windows and Linux, may have different configurations to enhance its security. It is recommended to regularly update the operating system with security patches in order to fix any vulnerabilities on the operating system. It is also considered a good practice to give the minimum necessary access to users for their job. Patch management. Patch management is the process of applying updates to software to fix vulnerabilities and improve security. Schedule regular updates to ensure that the latest patches are applied promptly, and test patches in a staging environment before deploying them to production to ensure that they do not introduce new issues to the system. We can use automated tools to manage and deploy patches efficiently across all systems. We use critical patch management, which prioritizes and applies critical security patches as soon as they are released. This is very important in the case of a zero-day attack or in the case of discovery of an important vulnerability. Sandboxing. Sandboxing is the process of running applications in an enclosed or isolated environment along with its dependencies. If there is any damage or any malware within an application, it is contained within the sandbox itself and is not spread to the rest of the system. It is also used to isolate data or access to other resources, data or to the network from other users. Load balancing. Load balancing is a process of distributing income network traffic across multiple servers. It helps us by minimizing response time and avoiding overload on a single server. Load balancer. Load balancer is a device or software that distributes network or application traffic across a number of servers. It can be configured to distribute traffic based on various parameters, and it can handle TCP connections, reducing the processing load on the backend servers. Load balancers also manage SSL encryption and decryption, reducing the strain of backend servers even more. A cache can be implemented on load balancers, which store frequently accessed data to quickly serve repeated requests. We also use load balancers to ensure critical data applications receive the necessary resources and bandwidth. Finally, a load balancer can also direct traffic to specific servers optimized for handling certain requests. Scheduling. Scheduling is the algorithm used by a load balancer to distribute incoming traffic. Most load balancers use the round robin algorithm, which ensures that all servers get some requests. This also helps us direct traffic to the servers with the fewest active connections. Affinity. Affinity ensures that a client session is always directed to the same server. It uses the client's IP address to route traffic consistently to the same server and cookies to maintain session persistence by storing session information in the client's browser. Active and passive load balancing. Active servers handle incoming requests and provide the primary response, while passive servers remain idle or perform minimal tasks ready to take over if the active server fails. Network segmentation. Many organizations segment the network in order to contain security breaches, improve performance, simplify management, and ensure regulatory compliance. Network segmentation can lead to better performance and is done using physical and logical methods. Physical segmentation. In physical segmentation, we use separate physical hardware in order to create isolated network segments. Each segment operates on its own physical infrastructure. Logical separation. Logical separation uses VLANs or virtual local area networks to segment a network at the data link layer without requiring separate physical hardware. Since we don't have to buy more hardware, it is cheaper than a physical separation. Screen subnet. A screen subnet or a DMZ separates an internal network from an external network, and by doing so, it gives us an extra layer of security from attacks originating from the internet. Extranet. An extranet is a network segment that allows controlled access from external entities such as business partners, vendors, or customers. It provides access to specific internal resources while maintaining security and privacy. Intranet. An intranet is an internal network segment used exclusively by an organization employees. It is accessible only to internal users, providing a secure environment for internal communication and resources. It also provides high bandwidth for communication. North South and East West traffic. East West traffic refers to data traffic that moves laterally within a data center, and North South traffic refers to traffic that moves in and out of the data center. Zero trust policy. It works on the principle never trust, always verify, assume breach, and least privilege access. It requires strict identity verification for every person and device, from inside and from outside. VPN or virtual private network. A VPN provides secure encrypted communication over a public network. This encryption often happens in real time. Concentrator. A concentrator is a device that aggregates multiple VPN connections. It manages the encryption and decryption of data and user authentication. Remote access VPNs. Remote access VPNs allow individual users to connect securely to a corporate network from a remote location. This is often used in work from home, traveling, and while using public Wi-Fi. SSL VPN. SSL VPN use SSL TSL to create secure and encrypted connection over the internet. It requires no specialized software and is accessible via standard web browsers. HTML5 VPN. This VPN leverages HTML5 technology to provide secure remote access through a web browser. We do not require any client softwares or plugins for the same and it works across various devices and platforms using standard web browsers. Full tunnel. Full tunnel VPNs route all of a user's traffic through a VPN tunnel regardless of the destination. The tunnel can never be broken and all requests and data have to go through the tunnel, which is why full tunnels are preferred for high security environments where all traffic needs to be monitored. Split tunnel. Unlike a full tunnel, in a split tunnel, some of the traffic is routed through the VPN tunnel and other is routed directly through the internet. It improves performance significantly but is riskier than a full tunnel. Site-to-site VPN. Site-to-site VPNs connect entire networks at different locations securely over the internet. It encrypts data between sites, ensuring data communication, and a firewall can act as a concentrator in this case. L2TP or Layer 2 Tunneling Protocol. It is a tunneling protocol used to support VPNs that is often used with IPsec to provide encryption and secure transmission. It connects networks over the network layer as if they were on the data link layer. Internet Protocol Security or IPsec. IPsec is a group of protocols for securing connections between devices in the network layer. It also provides encryption and authentication of the data. Transport mode. The data of the original packet is encrypted and IPsec headers and trailers are added before and after the data respectively, but the IP header remains intact and unencrypted. In tunnel mode, The header is encrypted and added before the data and adds a new IP header, authentication header or AH. It includes a hash of the packet and a shared key but does not encrypt the data. It helps us by verifying the integrity of the data, but the data itself is prone to leaking. Encapsulation Security Payload or ESP encrypts and authenticates the data. It adds an encrypted header and trailer, an ESP header and an integrity check value. ESP and authentication header can be combined with transport and tunnel mode. In transport mode, only data and ESP trailer is encrypted. But in tunnel mode, IP header is also encrypted and replaced with a new IP header. Port security. Port security here refers to the protection of physical network ports in order to ensure the integrity and efficiency of network traffic flow. Broadcasts. Broadcasts are network messages sent to all devices on a network segment. While necessary for some functions, excessive broadcasts can overwhelm the network. And in doing so, it degrades the network performance and increases the risk of broadcast storms. Broadcast storm control. A broadcast storm control is a feature that prevents network congestion caused by broadcast storms, which occur when broadcast traffic overwhelms the network. Loop protection and spanning tree protocol. A loop happens where two networks connected to each other send information or data to each other indefinitely. To prevent this, the IEEE standard 802.1d introduced spanning trees. Spanning trees work by detecting and eliminating network loops by blocking redundant paths. They also include backup links providing fault tolerance. Nowadays, we use RSTP or Rapid Spanning Tree Protocol, which provides significantly faster recovery in response to network changes or failures. Since STP takes time to configure, we can configure switches to save the position of devices connected to the to the switches or to the network. This can lead to potential misconfigurations, malicious attacks, or loops, which is why we use BPDU frames, which are special frames used by the STP. On receiving these frames, the port deactivates, removing any loops that might have been created. DHCP snooping. DHCP snooping is a security feature that monitors DHCP traffic and filters untrusted DHCP messages to prevent DHCP attacks. It creates a database of trusted DHCP servers and tracks IP address assignments. MAC filtering. MAC filtering is a security mechanism that restricts network access based on the MAC address of devices. It allows only specific devices with MAC addresses that are in the database to connect to the network. We can configure access control list or ACLs on switches to permit or deny devices based on the MAC addresses. It enhances security by preventing unauthorized devices from accessing the network. This is unsecured and can be spoofed because MAC addresses can be copied by other devices. This is also why it is known as security through obscurity. Secure networking, DNS and DNSSEC. DNS is the system that translates human readable domains into IP addresses that computers use to identify others on the network. DNSSEC is a suite of extensions that add security to the DNS protocol by enabling DNS responses to be verified. It protects against DNS spoofing and cache poisoning by ensuring the authenticity and integrity of the DNS data. It uses digital signatures and public key cryptography to sign DNS data, allowing resolvers to verify the source and integrity of the response. It also prevents attackers from redirecting traffic to malicious sites by ensuring users reach the correct IP address associated with a domain name. Sinkhole address. It helps us identify infected hosts, block malicious traffic, and helps in analyzing threat patterns, and redirects malicious traffic to a control IP address or sinkhole. Out-of-band management. Out-of-band management provides a method to manage the network devices independently of the primary network connection, typically using a separate management interface. It allows administrators to manage and troubleshoot network devices even when the primary network is down. QoS or quality of service. It refers to the technologies that manage network traffic to ensure the performance of critical application. It prioritizes traffic, reduces latency, manages bandwidth, and ensures reliable network performance. It also enhances user experience by ensuring critical applications receive the necessary bandwidth and low latency. IPv6. IPv6 is the most recent version of Internet Protocol designed to replace IPv4, offering a vastly larger address space and enhanced features. Unlike IPv4, IPv6 has enough addresses to assign a unique IP to every single device, eliminating the need for network address translation or NAT. It incorporates IP security natively for encryption and authentication, enhancing security. Taps and port mirrors. Taps are hardware devices that create a copy of the network traffic and send it to another place. Port mirrors copy network packets from one or more ports to another port on the switch for monitoring. Monitoring services. These services involve continuously observing network and system operations to ensure performance, security, and availability. It detects anomalies, performance issues, and security threats in real time and is done by a third party or tools. It also includes tools for network monitoring, application performance monitoring, and security information and event management or SIM. FIM or File Integrity Monitoring. It is a security technology that monitors and detects changes to files that may indicate a security breach. It is critical for detecting malwares, unauthorized access, and configuration changes. Some famous examples are SFC for Windows and Tripwire for Linux. Firewalls. Network based firewalls. Network based firewalls are deployed as strategic points within the network, such as the boundary between an internal network and the internet. They filter traffic to and from the network, providing protection against external threats. Stateful and stateless firewalls. Stateless firewalls filter packets based solely on predefined rules in the Access Control List or ACL without considering the state of the connection or context of the traffic. While firewalls monitor the state of the active connections and make decisions based on the context of the traffic. Unified Threat Management or UTM. UTM appliances combine multiple security functions into a single device, providing comprehensive protection for networks. It includes firewalls, intrusion detection and prevention, antivirus, content filtering, and VPN. It simplifies security management and reduces cost by consolidating multiple security functions. Since it is a unified security solution, we don't have to check the compatibility of softwares with one another. NGFW or Next Generation Firewalls. NGFWs offer advanced capabilities beyond traditional firewalls, incorporating features such as application awareness and control, integrated intrusion prevention, and cloud delivered threat intelligence. Web Application Firewall or WAF. WAFs specifically protect web applications by filtering and monitoring HTTP traffic between a web application and the internet. A WAF detects and blocks threats such as SQL injection, cross site scripting, and other web based attacks. It can be deployed as a hardware, software, or cloud based solution. Firewall rules. This refers to the traditional firewall, which runs based on an ACL or access control list, or ACL. We can add multiple rules on the ACL based on IP addresses, ports, protocols, and direction of traffic. Characteristics of firewalls. Open source versus proprietary firewalls. Open source firewalls are cost effective, customizable, but lack advanced features. On the other hand, proprietary firewalls often come with professional support, advanced features, and integration capabilities. Firewalls versus software firewalls. Hardware firewalls have better performance and robust security but are expensive. Software firewalls, on the other hand, are flexible and easy to deploy. Application firewall, host based firewall, and a virtual firewall. An application firewall is a dedicated hardware device that is reliable and has high performance. A host based firewall are installed on endpoints, which are application aware and provide granular control. Virtual firewalls are deployed as virtual applications in virtualized environments and provide east west security. It is ideal for cloud virtualized data centers. Network Access Control or NAC. An NAC enforces policies on devices seeking to gain access to a network. Only compliant and authorized devices are allowed to connect to the network. Edge and access control. Edge controls refers to securing the points at which devices connect to the network. Access control is the rule that dictates whether a device can gain access to the network. Both edge control and access control can be implemented physically or logically. Health checks or posture assessment. It involves evaluating the security status of a device so that it meets the required security standards. The security status is evaluated by using persistent agent, dissolvable agents, or agentless NACs. Persistent agents are softwares that are permanently installed on the device. Dissolvable agents, on the other hand, evaluate the security status and then delete themselves. An agentless NAC uses the built-in softwares on the devices to evaluate the security status of the device. If the device fails to meet the necessary security standard, full access is not granted. The device may be quarantined, it may get limited access, or it may be denied service, or it may try again after completing the requirements. Proxy servers. Proxy servers are intermediate devices that sit between the clients and servers. They are typically used for security and anonymity. IPS and IDS. A network intrusion detection system, or NIDS, monitors network traffic and raises alarm in case of suspicious activity. A network intrusion prevention system, or NIPS, detects network activity and also prevents any suspicious activity. Passive monitoring. Passive monitoring refers to analyzing a copy of the network data but does not affect the traffic at all. Out of band response. When malicious traffic is found, a signal is sent to other devices or applications to respond. This response is often sending TCP resets, which stop responses to malicious traffic. Inline monitoring refers to placing IPS or IDS device directly in the path of network traffic. In an in-band response, the device is placed directly in path of the network traffic and the packets are dropped in the IPS if they seem malicious. Identification technology. Signature based detection compares network traffics to a database of known attack signatures. It is effective for known threats but is unable to detect new or unknown traffic and attacks. Anomaly based detection. It establishes a baseline of normal network behavior and flags deviations from this baseline as potential threats. It also has the chance of generating false positives. Heuristic based detection. It uses algorithms and artificial intelligence to identify suspicious behavior based on experience and patterns. Behavior based detection. It monitors the behavior of entities such as users and systems and detects deviations from expected behavior. Network appliances. Jump servers. Jump servers serve as a control gateway between a trusted network and an untrusted network. It is used in highly secure environments to manage and audit administrative access. Hardware Security Module or HSM. An HSM is a physical device that performs encryption, decryption, authentication, and digital signing. It is widely used in industries where high amount of security is required for the data. It provides a robust security for key management, ensuring compliance with regulatory standards, and also protects cryptographic keys from physical and logical attacks. Sensors and collectors. Sensors are devices that capture network traffic, system logs, and more related to the network and system activity. On the other hand, collectors gather and aggregate data from multiple sensors for centralized analysis and reporting. Wireless cryptography. WPA2 and CCMP. WPA2 or Wi-Fi Protected Access 2 is a security protocol that uses AES encryption method for encryption and CBC MAC for message integration check or MIC. CCMP or counter mode with cipher block chaining messages authentication code protocol or CBC MAC. AEC using which is essentially AEC using counter mode with CBC MAC or CCM. The WPA2 PSK problem. The problem with WPA2 is that the same pre-shared key is used by all devices on the network, which is why it is vulnerable to dictionary attacks or brute force attacks. Attackers can listen to the four-way handshake to find the hash key used for the pre-shared key. Brute force seems to become easier as technology gets better. To address this issue, we now use WPA3, which uses the GCMP or Gallios Counter Mode protocol for encryption, which provides enhanced security compared to CCMP. MIC is done with Gallios Message Authentication Code or GMAC. There is a mutual authentication to avoid the WPA2 PSK issue from the client side and the server side. The shared session key is created but not sent across the network. Wireless authentication methods. Wireless security modes. Wireless authentication protocols and routers are highly configurable. It can be open, which means there is no authentication or encryption. It can have WPA2, WPA3 personal or PSK, allowing for both encryption and authentication. We can also have WPA3 Enterprise or WA3 802.1x, which is the industry standard and provides high security. Captive portal. A captive portal is a web page that users must interact with before accessing a public network. It also allows for other features such as authentication, agreeing to terms of service, or being able to pay for Wi-Fi services. EAP or Extensible Authentication Protocol. EAP is a framework used for transporting authentication protocols. It supports various authentication mechanisms such as passwords, tokens, and certificates. IEEE 802.1x. This is a standard that does not allow access to internet unless authentication is done. It uses EAP for authentication and an access database to verify the credentials. It has three components: the client, which is the device attempting to connect to the network, the authenticator, which is the network device that controls access to the network, and the authentication server, which validates the credentials of the supplicant or the client. EAP and 802.1x authentication methods. EAP Fast or EAP Flexible Authentication via Secure Tunneling. Developed by Cisco, EAP Fast is designed to provide secure authentication without the need for certificates. A TLS tunnel is set up after receiving the PAC or Protected Access Credential to establish a secure tunnel for authentication. PEEP or Protected EAP. It encapsulates EAP with a secure TLS tunnel where we use a digital certificate instead of a PAC. It integrates seamlessly with Microsoft MSCHAP version 2. EAP TLS. EAP TLS requires certificates in all devices in order to perform mutual authentication. It is complex and hence secure. EAP TTLS or EAP Tunnel TLS is similar to PEEP but allows additional authentication methods to be used within the secure tunnel. Radius Federation. It uses the Radius protocol to authenticate users across multiple domains or organizations, which means that an employee working in a one location can access the data of from all locations of the organization. Installation of wireless networks. Site surveys. Site survey refers to assessing the physical and radio frequency environment where the wireless networks will be deployed. We need to identify existing wireless signals and other sources of radio frequency interference such as microwave ovens, cordless phones, and other Wi-Fi networks. Wireless survey tools. Wireless survey tools provide detailed information about wireless environment and help us survey the sites for wireless installation. These tools use heat map for visual representation of signal strength and coverage. Wireless packet analysis. It refers to capturing and examining the data packets transmitted over a wireless network. Some popular tools used for the same are Wireshark and AirCrack NG. Channel selection and analysis. The 2.0 gigahertz band. Channels 1, 6, and 11 are non overlapping and commonly used to avoid interference. So, for example, if channels 1 and 11 are being used around the area, we shall use channel 6 to get the least amount of interference. 5 GHz band. It offers more non overlapping channels, reducing the likelihood of interference. Access point placement. Access point placement. The access points need to be placed in such a way that it ensures adequate overlap between APs to avoid dead spots but not too much to cause interference. It needs to be noted that we need to minimize physical obstructions like walls and furniture that can attenuate signals. Wireless infrastructure security. We can use wireless controllers, which is used to manage access points and connects to the PC via HTTPS protocol. We use it to make sure that the firmware is up to date and all the devices connected to the network are authenticated